Hey guys, this is Mrs. Tran-Bloom. Welcome to trigonometry. This is second semester pre-calculus. So let's talk about this semester. Okay, so this semester, which is second semester of pre-calculus, we're mostly going to focus on trigonometry. So we're going to start with this packet right here. This is chapter 6 and a little bit of 8.1. Okay, 8.1 is pretty much a review of geometry. So yes, you do need to know geometry. First semester, you definitely needed to know Algebra 1 and Algebra 2. Second semester, you definitely need to know geometry or the trig piece of geometry. Okay, so the first front page of your packet, you see this funny looking circle with lots of lines here. We're gonna fill this in later in the unit. Okay, so right now just put your name here, your period, and leave this blank, and don't worry about this until much later. Okay, so now I'm gonna flip over and do the very first units here of notes. Okay, so here we go. So I'm going to zoom in really quickly so we can focus, right? Everything looks okay. Alright, so we are starting trig, and I have my pens. I have a couple of different pens and pencils going on, so just in case I need to change colors. Alright, so the first section is we're adding 8.1 to our particular chapter 6. Just the first half of 8.1. The second half of 8.1, we're going to wait until chapter 8. Okay. So with this, we're going to start with the right triangle. Okay. So the right triangle, if you can recall from geometry, we can use Pythagorean theorem. Okay. So Pythagoras said, hey, if I take this base and I square it, add this base, okay, and I square that base should equal to the hypotenuse square. So here we go. A square plus B square equals C square. This is only true if this is a right triangle. And similarly, then you can also switch it, right? B square plus A square equals C square. Okay, so, oops, it's supposed to be B square. B square plus A square equals C square. Okay, because addition is commutative. So in geometry, you study the right triangle trig. So this is red sine, and we're going to abbreviate this as a SIN. And sine usually is going to be accompanied with an angle. Let's call it theta for now. Okay, so sine of theta equals to, okay, so remember SOHCAHTOA, sine of this angle. Actually, you know, let's use B. Okay, so sine of B. Sine of B equals opposite over hypotenuse. Equals opposite over hypotenuse. In our particular right triangle, opposite is B, hypotenuse is C. So B over C. Okay. I can also do sine of A. Sine of A equals opposite, which is A, over hypotenuse, which is C. So pick an angle, and that's what we're going to go with. In this case, I'm going to pick angle B. Okay. All right. Cosine. We are going to abbreviate this as SOS, and cosine, we're going to accompany that with an angle. Again, I'm going to use B. I keep using theta. That's what I'm used to. Cosine of B. Cosine equals adjacent over hypotenuse. So adjacent in this particular triangle is A. So I'm going to spell it out first. Adjacent over hypotenuse. Okay, and you should spell this out. Okay, opposite over hypotenuse, adjacent over hypotenuse. If you don't remember this stuff from geometry. So cosine of angle B equals adjacent, which is A, all over hypotenuse, which is C. Okay, and if I were to pick angle A, then adjacent of that would be B. Hypotenuse with that would still be C. Hypotenuse is not going to change, right? Tangent, we're going to abbreviate this as TAN. We're going to accompany tangent with B. Okay, so tangent angle B equals opposite over adjacent. Okay, so SOHCAHTOA. Okay, so opposite is going to be, this is B, go opposite of that, which is leg small b. adjacent, which is the leg that's next to the angle, which is A. Cosecant. Cosecant abbreviation is CSC, and accompany that with beta. Oh, I'm sorry, not beta, B. Okay? Cosecant of beta, which is B. Beta is kind of Greek letter for B. Alright, so cosecant letter B. Cosecant, the relationship of cosecant is going to be the reciprocal of sine. So you can do 1 over sine of B. Okay? So cosecant is the reciprocal of sine, which is 1 over B. Now, if sine of B is opposite hypotenuse, then cosecant, if I were to take the reciprocal, would be hypotenuse over opposite. Okay? Which is, if I take the reciprocal, which is C over B. Okay. So if you know the main three, which are the first three trig functions, then you're going to know the rest of these. Because these three, the remaining three, are just the reciprocal function. Alright, secant, we are going to abbreviate this with SEC of angle B. Secant is going to be the reciprocal of cosine, so 1 over cosine of B. And if I were to take the reciprocal, then now it would be hypotenuse over adjacent. Hypotenuse over adjacent. But if I were to take the reciprocal, it would be C over A. Okay. Cotangent is going to be the reciprocal of tangent, but we're going to abbreviate this with COT and angle B again. Okay. So cotangent of angle B, reciprocal of tangent. So I'm going to write 1 over tangent. Okay. 1 over tangent, so if I were to take the reciprocal of 1 over tangent, it's going to be A over B, or adjacent over opposite. So adjacent over opposite equals A over B. Okay, so this right here, it's all review from geometry. Okay, so none of this should be new information to us. But if it is, then just carefully copy this down and try to understand, you know, these three are pretty much the reciprocal function of those three. Okay? All right. So now we're going to try to do A. Although I don't have the direction here for A. So I'm trying to see what I want. What are we doing on A? There's no direction. What's going on with that? Okay. So A, I think when I was trying to move it down, it became something happened. So just give me a second. Let me look up what's the direction for. Alright. Well, since I don't know what the direction is, we are just going to fill it in. Alright, let's see what is the direction. Sorry, I'm looking at my own note to see if I have the directions written down somewhere. It's really strange that I don't have that. Okay. Well, since I don't have it, this is supposed to be, I think this is example 1. Let me look at the back. Excuse me. Excuse me. Alright, so I think this is supposed to be example 1. Because what happened was when I was trying to make this fit in one page, this box was moved down. So since this box was moved down, it covered up the directions here. So this is supposed to be example 1. And I'm pretty sure I'm asking you to find the exact value of, I think this is solve for the triangle. Okay, so solve for the triangles. Okay. Alright. So solve for the triangles. That means if you're solving for any triangle, you're going to find all of its missing pieces. Okay, so here's the first one. This is a right triangle, so we know Pythagorean theorem. We can use Pythagorean theorem. Pythagoras theorem. Okay, I can't speak right now. Okay, so if this is 40 degrees in a triangle, you know the total measurement is 180 degrees. This is a right triangle, so that's 90. This is 40, so angle B. So let's write down all the missing parts. Okay, missing parts. All right, missing parts is we have angle B, We're going to fill that in a little bit. Looks like we have this measurement is 2 units. So this is little b, it's 2 units, which I don't need to find because it's already there. But I do need to find angle A. Opposite of, I'm sorry, not angle A, leg A. Opposite of leg A is always angle A. And opposite of angle C is always leg C. So since I know this is leg C, this is angle C. Angle C is not missing because you know that this symbol right here means it's 90 degrees. So I just have to find leg C and leg A. Okay, so little a represents leg A, little c represents leg C or the hypotenuse. So I'm missing 3 parts. Okay, I'm going to box this up. And I'm going to do the work over here. Once we have the answer, we'll just fill that in. Okay, so we're going to find angle B first. Angle B equals 180 degrees. Take away this symbol right here means 90 degrees. Take away this measurement right here, 40 degrees. So angle B is going to be 180 minus 90 is 90. Minus 40, that's 50 degrees. Okay, so angle B is 50 degrees. Alright, so now we're going to need to look for leg A or hypotenuse C. Since I'm missing 2 of these, I can't really use Pythagorean theorem. Pythagoras said, hey, it's a squared plus b squared equals c squared. Since I have 1 equation and 2 variables are missing, I can't use Pythagoras. But I can definitely use trig function, which is what we have up here. Excuse me. Since this angle is known or given to me, I'm going to use this angle. And I have adjacent, and I don't have the hypotenuse, so I'm going to go ahead and find the hypotenuse. Okay, so adjacent and hypotenuse, if I look at my box up here, which one of these right here is going to help me out? Which one's going to have adjacent and hypotenuse all in the same ratio? It's going to be cosine. So we're going to go, hey, cosine, this is 40 degrees, which is angle A. So cosine of 40 degree equals adjacent of that, which is 2, over hypotenuse of that, which is letter C. Okay. So now we're going to need to talk about calculator usage. Now that you are in trig, you're going to need to know when to change it to degrees and when to change it to radians. Okay. Check this out. The original function said this is cosine of 40 degrees. So I'm going to need to go to mode. Okay. Currently, my calculator is in radian, which if I keep it the way it is, if I just go and quit, okay, if I keep it the way it is, I'm going to get the wrong answer. So you need to be smart enough to go, hey, you know what? My problem is in degrees, so I'll have to change my calculator to degrees. Okay, so I'm going to hit mode, go to degree, hit enter, and then quit. Okay, let's go that again. To change your calculator from degrees to radians, hit mode. And then right now, notice how I can go to radian and hit enter. And then it's now in radian. But because my problem is in degrees, so I'm going to need to go and change it to in degrees. You only need to do this when you are in trig. Okay, so now my calculator is in degrees. Okay, so now I need to solve for my C. And I don't want you to round until the very, very, very last step, right? I'm going to cross multiply, so this is now over 1. Okay, let me get a different color pen. So when I cross multiply, I would have C times cosine of 40 degrees equals 2. Then I'm going to divide both sides by cosine of 40 degrees. Again, don't round until the very last step. Okay, and you do need to write the bubble right here to represent degrees. If you don't write the bubble, then I'm just going to assume that it's going to be in radians. Okay. Oh my goodness, what did I just do? This is supposed to be equal to 2. Okay, so now C equals, I'm going to punch in my calculator. Here's my clear screen. 2 divided by, cosine is this button right here, cosine, 40 degrees, so hit 40, and then close that up, hit enter, and then let's just round it to 2 decimal places. Okay, so C is about 2.61 units. Okay, so that's my C. So C equals 2.61 U. Okay. So now that I have hypotenuse, I have leg B, I can just go and use Pythagoras to find leg A. But because we're in trig, let's try to practice using trig anyway to find leg A. Now to find leg A, it's probably best to use the exact values that are given to us. So I have this measurement right here, which is 40 degrees. I have an adjacent leg, and I'm looking for the opposite leg. The one trig function that's going to give me opposite and adjacent is either tangent or adjacent and opposite, which is cotangent. Okay, so right now we can use tangent of 40 degrees to find that. So tangent of 40 degrees equals tangent opposite, which is little a, over adjacent, which is 2. Okay, I'm going to make this into a fraction so I can cross multiply. So check that out. I can cross multiply, so I have 2 times tangent of 40 degrees equals little a. A times 1 is just going to be itself. So now I'm just going to punch this entire piece into my calculator. You can't really take cosine or tangent or sine of these angles without the calculator. So now all I have to do is punch in 2 times tangent of 40 degrees. So 2 times tangent of 40 degrees and close that. Oh, my calculator is stuck. This button right here is so stuck right now. I think I spilled some coffee in my purse. Alright. Let's clear that out. Sorry. 2 times tangent of 40 degrees. Here we go. Hit enter. So that's about 1.68 rounded to 2 decimal places. So A comes out to be 1.68 units. Okay, and again, this has to be in degrees mode. So if you check your calculator, it should be in degree already from the previous step. Alright, so I'm going to fill that in, 1.68u, and those are the parts that are missing. So it says solve for the triangles, meaning that you're going to have to find pretty much anything that's missing from each triangle. Okay, let's do this one. And then I believe, so what I'm going to do is I'm going to ask you to do this on your own. Okay, so notice how this triangle right here is given to you. This is a right triangle because it has this little box here. Check out this angle. It's called theta. This is called theta. T-H-E-T-A. Okay, it's spelled theta, or it's pronounced theta. I'm giving you 2 legs here, or a leg and a hypotenuse. Since it's not given to you, since this leg is not known, this angle is known as theta, then you can say, hey, you know what are my missing parts? Okay, since this is the only part that's labeled, you can also label this. Let's label this alpha. Okay, it looks like a fish. So missing parts are, I'm gonna set this up for you, and then your job is to find it on your own. I'm missing this angle, this angle. This is known. This is 90 degrees. Okay, so missing parts are angle theta, angle alpha. Okay, this leg is known, the hypotenuse is known. Since this is this leg is not labeled, so you're gonna label it. Let's call it T. Okay, so leg T, it's unknown. So these are the 3 missing parts. All right, we'll box that up, and then your job is to find those 3 missing parts. Now this is sort of unique because you don't have any of the angles, so I'm gonna kind of give you a hint on how to start. I do have an adjacent, okay, of this angle theta, and I do have a hypotenuse of this angle theta. So adjacent and hypotenuse, if I look at those trig functions up here, I can use cosine or I can use secant. But usually I'm going to use the first 3. So I'm going to use cosine. Okay, so I'll set this up and then I'll help you finish the rest. So we're going to know, hey, cosine of angle theta, which is something that's not known currently, equals adjacent, which is 2, all over square root of 5. Well, I need to solve for theta. So what we're going to do is going to go in and take the inverse. Okay, so the inverse is this symbol right here, which is also on your calculator. Okay, so if you look at the sine and right above it, sine inverse, cosine, cosine inverse, tangent, tangent inverse. They're inverses of each other, meaning that they're going to undo each other. So I'm going to do cosine inverse. I'm going to take the cosine inverse to both sides. Okay, what you do to the right, you have to do to the left, and what you do to the left, you got to do to the right. So if I go take cosine inverse of the left, I'm going to have to do cosine inverse of the right. Okay, So because these two are inverse of each other, they typically cancel each other out. So now you got theta equals cosine inverse of 2 over square root of 5. So we are going to use our calculator. Okay, so it'd be in degrees mode, which what we already have before. So we're going to say, hey, there's a button on the top of cosine right there. I'm going to hit second cosine. So you notice how the cosine inverse function pop up. 2 divided by square root of 5. Close it twice. Okay, so I need to close that twice because one is for the radical and one is for the denominator. And we're going to hit enter. So currently it said, hey, it's 26.57. Well, what kind of unit of measurement is this? This is theta is an angle, so you got to go in and put degrees. So this is theta equals about 26.57 degrees. Okay, so that's what we need to fill in. So 26.57 degrees. Okay, so now that you know what this is, you can definitely find alpha. 100 degrees, I'm sorry, not 100, 180 minus 90 minus theta should give you alpha. Okay, then now that you have alpha, you can easily find t. Okay, so on your own, I'm going to spell this out. On your own, find alpha and leg t. Okay, all right, go ahead and hit pause. Complete that on your own, and I will check this tomorrow. Have a great day.